Okay, so Kurt, you've got us squared away. It's perfect. Awesome. Here, I'm gonna put us up on the big screen here.
Oh, yeah, good luck there, guys.
Hey, thanks. All right, it looks like we got a good crowd in here. I'm gonna go ahead and get us kicked off. Well, I appreciate everyone coming today. As usual, we have a good crowd. We actually have some professional pilots that are here in a professional pilot program. So we've got some students here for that. And today we have Dr. Kurt Barnhart, who's going to step us through the Master of Science in Aeronautics in our Aeronautics graduate program.
You got it. All right. Thank you, Mike. And good morning, everybody. I think I know many, if not most of you. For those that don't, been with K-State for going on 17 years. I was started at K-State as aviation department head, then was associate dean for a while. And now I'm just full professor, senior professor of aeronautics, and am working remotely from the East Coast. So I wanted to give you an opportunity to understand the Master of Science in Aeronautics a little bit better. And thank you, Dr. Pritchard, for giving me the opportunity. So it is, and I'm not going to do a disclaimer. This is my second attempt at using artificial intelligence to generate slides. And so I typed in the content, and so I tried it once about a month ago, and it worked out so well. So I thought I'd try it again. So I'm pretty impressed. It's called Slides AI, costs $10 a month for small presentations and $20 for bigger ones. Give it a try. It's if you do a lot of presentations, it works pretty well. So all right, so this what we're going to do is give you an overview of the Master of Science in Aeronautics program at K-State, which is based out of our campus. It is 100% online. I didn't get a chance to put that in, but this is a program that can be done fully online. We're working on being able to do that fully asynchronously right now. We don't have that quite up and running yet, but I'm going to talk about the origins just a little bit, focus areas, and the impact on the aviation industry. And so where we start in aviation and aeronautics is it's all about safety. Of course, we want to get people to and from and cargo to and from places more efficiently with less cost. But at the end of the day, if we can't do it safely, we don't do it. And so that's really what we focus a lot on in the MSA program. If you look at that chart there from Statistica, if you look back to the early 1970s, and it gets much worse prior to the early 70s. I mean, it's gotten steadily better over the decades, and we're talking about specifically airliner accident fatalities by year, and that is a really good trend line. And we want to keep that going, and we have been, really blessed over the last few years with excellent safety globally. And the challenges that we face are obstacles to that record. And so what our challenge is as an industry is to continue to improve upon, not just maintain, but improve upon the level of safety that we've so enjoyed while we operate in a highly complex environment. The challenges that we face are sticky challenges, wicked challenges. They're interdependent and highly complex. And so that's what we focus on. So it's approximately 15 months old. We first had students fall of 22. It was about a year and a half, 2 years before that we started working on the program, but finally took students about this time last year. We'll hopefully have our first graduate in December of 23, at least one, maybe two. And so going back to the late teens, 2000 teens, 18, 19, the need for this degree program came out. It was one of the most poignant needs that came out of the Global Aeronautics Initiative, which then led to many other planning efforts and, that have emerged in their various forms. But one of the things that we knew we needed was to get a graduate program on our campus and be able to generate grad students, not just masters, but ultimately PhD, which we're talking about that already, and we've got the wheels in motion. So it's exciting. The demand for the program, though, that's one of the first places that you have to start with one of these programs. And KBOR makes it clear there has to be clear demand for the program. So we identified that through a comprehensive analysis process that involved a lot of literature review, current and mostly current, obviously current events. So an extensive literature review, faculty input, student input, alumni input, and we had a lot of working professionals, and then some C-suite level folks, executives with airlines. And I was able to parlay some of the research that we did for the Global Aeronautics Initiative into this program when they started talking about the people that they wanted to see to help solve the problems. And that was the biggest thing that I got out of that session, where we interviewed, I believe it was 50 senior level managers, aviation, from Boeing to Airbus to United, Delta. They all basically said, we want problem solvers. We want people who can come and help us solve problems. We don't want people just to come and do a specific job. We want people who can help us think through the immense challenges that we face, not the least of which is workforce. Where do we find the workforce? But emerging technologies, new fuel sources, environmental constraints, there's just a host of problems that the industry faces. And so that was what they said. So the background is that once we got that input, we further refined that to focus on speeding the introduction of new technologies to market, specifically in the aircraft certification option, but not exclusively. So focusing on emerging problems. And one of the biggest emerging problems or challenges that we have is, how do we get new technology integrated, AAM, multi-rotor? How do we incorporate that into routine operations? It's one thing to do it on an experimental basis. You can do just about anything in restricted airspace, but to do that on a routine basis, where we have a very crowded airspace system that's very regulated, that demands a high level of safety. So how do we do that? And so we do focus on that. So, basically it originated from the identified needs for advanced education in both technical and the management policy aspects of aeronautics. And so there are two options. We have this aerospace certification option, and then the leadership and policy option. Those are really, when you look at it, the two broad areas that most impact aviation safety. And it has to do with the design and production and the maintenance of aircraft on one end, and then the management and operation of or the management of operations on the other end. So those two areas together, they encompass what we do in aviation and aeronautics. So and there's a number that we talk a lot about, especially in the Aero Cert option, and it's 10 to the -9th. And I don't think the UAS folks are there because they had a conflicting meeting, but I'm pretty sure they're going to be familiar with 10 to the -9th. Anybody else understand or want to talk about what 10 to the -9th means when it comes to aviation safety? Anybody know? Okay, I don't see. I got a real small picture so I can see my slides, but I don't see any hands. So 10 to the -9th is the level of safety to which we have to certify, or so we have to get there either in a quantitative way, or we have to find an equivalent level of safety to get to the probability of failure being 10 to the -9th. In other words, extremely remote. So if we're going to certify a new technology, the chances of that system failing or that component failing need to be 10 to the -9th. Obviously, they do fail. I mean, failures are not unheard of, but thankfully they're very rare. And we do that. We're able to do that because of a very rigid certification system. And learning how to navigate that is really important. No technology gets into or goes through the National Airspace System without a certification basis, at least on a routine basis. Obviously, like I said, we can do anything once, twice, 10 times, but when we start charging people to do it routinely, the standard changes rather dramatically. And when we look at space operations, 10 to the minus ninth right now is not achievable, and everybody will tell you that. It's more like 10 to the minus 2, maybe. And so we have to look at a very different risk equation when we talk about space ops, just because of where the technology is. So anyway, that's what that's about. We go into some depth. We talk about that. But understand that certification at many levels is the key to the National Airspace System. And I'm talking about certification of everything from the materials we get out of the ground, to the way we handle those materials, to the way they're assembled, to the way we train people, to the way we regulate airspace and ground operations. It's all about that. So anyway, I want to not drag out too much, because I know we've got other things to talk about. Let me go on to the next slide. So nothing new here. There on the right, the Master of Science in Aeronautics aims to contribute to safe operations by providing knowledge and specialized knowledge and skills in aircraft production, maintenance, operation, management, and policy. So in addressing these areas, it provides opportunities for students, and when we dive into these topics, students become a lot more knowledgeable and conversant about these technologies, and are able to lead discussions. And when they get into the workforce, they're knowledgeable about these things. So the industry, like I said, faces just unprecedented challenges. I mean, there are the surety of the fuel supply, the type of fuel that we're going to use, the need to cut down emissions and eventually eliminate emissions altogether. Workforce is just a tremendous challenge right now. When we look at the aging, particularly, well, it's all over the board, but mechanics and engineers, pilots, that shortage is just amazing. Only 27% of mechanics, aircraft mechanics, are under 30 years old, which, that you have an aging, a workforce with a bubble towards the retirement end. And so fixing that is going to be a challenge. We have a critical shortage of engineers. This was an article from earlier this year. You still got me, Mike?
Yeah, we do.
Okay, gotcha. Critical shortage of engineers. It's a looming crisis across all levels. So we have to get creative in how we solve that. So let's just dive in and look at the degree, the mechanics, so to speak. And I'm going to move my bar here. I know you can't see this, but there we go. Okay. So there's 4 ways to really interface for students with the programs. You got the full-blown master's degree. There are two standalone certificates. So they're 4 classes each, 4 classes each, or 12 credit hours. They're 4 3-credit classes that seamlessly transition into the degree, and we'll look at those. These students can take these as elective courses. And then there's also in the works an accelerated degree program that we did the proposal for last year that's working its way through. And this is primarily right now for pilot students, because pilot students have room in their degree to do the accelerated program without adding any more classes. They still have, they can do it within their 120-hour requirement, because they have room for those electives. Other aviation degrees currently don't have room for the added electives, but it doesn't mean that students in those degrees can't do that program. They're just going to end up taking an extra 1 or 2 classes beyond their 120 for the undergraduate degree. And, well, I want to try to, there we go. I'm going to go, button stopped working. So The degree requirements, there are 3 common classes to both options: 611, 701, and 707. So regulation and certification is really a leveling course. It's a baseline course. It's where students that don't necessarily have a strong aviation background can come in and get that baseline and understand what makes aviation unique, which is an understanding of the regulation, the regulatory structure, and how we operate safely through certification. But all students have to take it, and it's just that those that come with an aeronautics background are going to have a little bit easier time or a less steep learning curve in that course. Then we have advanced technical communications as well as research methods, and then from there you can see, I'm going to move my little dialog box again. For the cert option, you can see the courses there, and then for the leadership and policy option, underneath there, you can see what courses you're going to be taking. So leadership and policy has a couple of different elective options, whereas the certification option is pretty prescripted or scripted or prescripted. There's not a lot of extra room because the advisory council, the industry advisory council that helped me put this together, wanted to see so many areas specifically covered in that option that we ran out of room. And so project management is a course that we're working on now, and hopefully we'll be able to offer that next year. That it will be the last class that we have not offered yet. But it was not required for those that came in last year because we just did that curriculum change last year. So it's only required right now for new students that are admitted to the program. Leadership and policy, Dr. Austin Walden is helping me to deliver this option. But we have other faculty as well. Eric Chappé, Professor Chappé, is helping with the safety management system, that course. And we have Cindy Joseph, Professor Dr. Joseph is helping with research methods. Dr. Ackerman is advanced technical communications. And so we've reached out across campus and tried to bring in a broad range of faculty for many of these courses. And then for these two, I don't know if you can see my pointer, but for 722 and 734, I've got industry subject matter experts delivering the content for those 2 courses, because certification, that skill, when it comes to type and airworthiness certification, isn't a skill that really resides in academia. It resides in the workforce. And so I've invited them in, and they put together the coursework for that, those 2 courses. All right, so those are the options. Go next. Elective courses, and this needs to be actually updated the more I think about it, but we have elective courses that we can put on here. There are several new is the elective courses that can be excuse me, taken as well. So, and then the last thing, hang on one sec, I gotta pop up. I think somebody may be on Teams. All right, so the capstone or thesis requirement is the wrap up. So if you're going to do the non-thesis option, you have a capstone course, and you have the option of doing either a thesis, which is a 6 credit hour experience. And now the course is actually variable from 1 to 6 hours as opposed to 3 to 6. So what we want to do is get students started early taking thesis, that coursework, so that they can work on the thesis all throughout their program. But for students that don't want to do the thesis, and the thesis is more appropriate for those that know that they want to go on and follow this on with a doctoral degree. For those that don't want that, then we can do a capstone project, which is a wrap-up project. All right. These are the 2 standalone certificates. There's one in aerospace certification and one in aerospace safety. So for those students that just want that particular knowledge set, they can get that. And then the good news is those certificates transfer seamlessly into the degree program, but it is a credentialed certificate. It shows up on a transcript as an academic certificate. So these are options for those that want to start with, a less coursework, or maybe that's all they need. This I know is very small. And so let me want to stop that share. And I'm going to go, actually, let me go do this. I'm going to bring up, nope. Fake out. Let me bring up, see if I can bring it up here. There it is. This is the proposed accelerated degree program. This is in a nutshell what we're going to expect from that program. This allows students who are pursuing, they haven't finished their undergraduate degree, to jump into a master's program with some of their elective coursework and get a jump start on their master's degree. And so they can take 9 hours towards the MSA while they're an undergraduate student, and the time and the cost savings are significant. So students have to be enrolled in the BSAT bachelor's program. They have to have a 3.0. They can apply when they get at least 75 hours towards their undergraduate degree. Students need to meet all other grad school admission criteria as outlined in the grad school handbook, and then they can be into this program. If accepted, students will be admitted on a provisional basis. So we admit grad students sometimes provisionally, with the provision being that these first courses are completed successfully. And once that 9 hours is completed with, I think it's in grad school, you want to get an A or a B in grad school. Getting a C in grad schools, it's kind of like an F. So if you're successful with those courses, then you can make it into the program fully admitted. But these are
Dr.
the
Barnhart. Oh, there
yeah.
you go. That's what we were looking at. Yeah, if you
Okay.
zoom, you could probably zoom in, just hit the plus button, just 1 or 2 on the and see if it gives you. And then if you, yeah, there you go. Might be a little, yep.
Okay.
Then you can.
All right.
Hit the arrow
Yeah.
right there. If you hit that little arrow.
There we go.
Yeah, that should. There you go. Perfect. Looks good. Yep. Good deal.
All right. Yep. Okay. So those are the 3 courses. The 3 common courses are the 3 that you'll start with in that program that transfer directly in 611, 701, and 707. And these are just diagrams that talk about, just show you what's, how the degree program progresses. There's actually 21 hours remaining. Apparently I can't math in public anyway. And so that goes into the MSA program. You probably could do it in 2 semesters, but I think it's more like 3 semesters for most students. I do have occasionally students that are just, for whatever reason, they like to blast through coursework, and if they've got the time to dedicate to it, it can be done, but it's not recommended. So I would say it's more like 3 terms if you want to go at a pretty good clip before you can finish. And that's the long and the short of it. We don't have this approved yet, but it is in the process and it's making headway. So, and I think I'm going to go back. I'm going to stop that share. We're going to share.
Monica has a question.
Okay. Yeah.
For the students who are in the bachelor's program and say, yes, I want to, transfer this stuff, and they apply and get accepted, are you going to waive the application fee at that point? Or will they have
Mike, that's a good question for you. Sorry to step on you there. Yeah. We've talked about that, things like that. So
they have not, just as an FYI, and that's a great question. The grad school has not waived the application fees. So they are lowering it, but they haven't waived it. So $25 or $30. So yeah.
Yep. So that takes me through the slides.
But that's not us
making
that decision. That's grad school. So they set the tone for that. Yeah. No, it gets a little bit more complicated too, because one of the things we're requesting is if you already applied to, let's say if it's stackable, let's say you go and apply to a grad certificate, you pay the $50, and then you shouldn't have to turn around, and if you're dual enrolled, you shouldn't have to turn around and then pay another $50 for the master's program that you're stacking into. But today, that's what's happening. So if you, for every program you apply to, it's a $50 application fee. And we're trying to figure out a way to, like, if you paid one time, then and then you immediately apply to another program and you dual enroll, then you shouldn't have to pay for it. So this second time. So it should just be one fee. Yeah. Yeah. That's what we're trying to work on. That's something that's an active discussion right now. So
Yeah. Any other questions on these slides?
I have a couple questions. Let's see if we've got, let's see. No, that was Professor Akin. Okay, so Professor Nichols, yes.
I'm back on that 10 to the minus ninth certification requirement or risk relationship. That is a hugely difficult goal, in my opinion. Are we talking about the hardware requirements, let's say, for communication, electronic warfare, or safety, all the things that come into the play for an airplane? Or are we talking about hardware and software related concerns too? Because 10 to the minus ninth is quite a few zeros on the right.
It is, yeah. And that has been, gosh, for decades, we've used that number for hardware and software as the standard, the gold standard. Now, obviously, there are situations where, that particular probability can be adjusted, but in aggregate, so as the systems work together, the probability of a failure producing a catastrophic event has to be 10 to the minus 9, not necessarily a light bulb burning out or something like that happening, but it's when it comes to the probability of the loss or failure of that component producing a catastrophic failure, which would be a loss of an aircraft, then it's 10 to the minus 9th.
As a follow-up to that, if I may, as you know, we look at jamming and spoofing situations on navigation, and especially GPS related, and we've looked at with Kurt Carraway and so on, looked at alternative systems, but none of those are looking at 10 to the minus ninth in practice. That doesn't mean we can't get there. I'm just saying some of these are down to 10 to the minus fifth, which is pretty good. Not great, but pretty good. And the electronic warfare ones that we see on the Navy is also specified at 10 to the minus ninth. And some of them on the hardware can reach very close, as Dr. Saeed can tell you. But even that's a tough haul. Do you see this happening within a reasonable period of time? Is our technology moving in such a way as to make this happen, or is this going to be kind of the gold standard?
I think it is. It is the gold standard. Now, when we talk about ELOS, which is short for equivalent level of safety, that becomes a very different discussion because it becomes somewhat subjective, and there is subjectivity involved. We can't necessarily quantify the risk in numbers, and so, but I think to achieve the safety record that we have become accustomed to, we have to keep that in our sights. Now, I've seen 10 to the minus 7th, 10 to the minus 8th as being acceptable in certain situations. But again, that overall risk has to be, I think, low when we talk about putting new technology into the airspace, flying alongside fully loaded airplanes and flying over populated cities. We just have to, I think the certification process is going to be slow until we can demonstrate that safety case. But we're paving new ground. I mean, this time period that we're in, we haven't seen this much disruption since really the late 50s and early 60s when jet aircraft were introduced. That was the last major system transition that we had. We've integrated automation slowly since really since the 50s and 60s. But the major transformation that comes in integrating uncrewed systems and AAM into the airspace is unprecedented as far as a challenge. And so we're working through that. Those discussions are happening every day right now. And they're real significant discussions, but it's an interesting topic.
Thank you. Let me pass it back to the team. Thank you very much, Kurt.
Hey, Kurt, this is Saeed. I
Yeah.
was just wondering, okay, so if you have got multiple systems, especially towards navigation, maybe in the AM field, right? You've got redundant systems there. So would each one of them have to be like out for certain time period before you can you can still pass that 10 to the power -9 thing that you're talking about in terms of all of them, right? So you have a so when you do have these backup systems, what is it that would it get to a
It can have
more,
a cumulative effect, right?
yeah,
It can become cumulative, right? Yeah, definitely. It's remember, it's the overall probability of a catastrophic failure.
Mhm.
And so
Okay.
you can start to stack those and stack probabilities for sure. It's, if you have system redundancies, then yes, that is acceptable.
Yeah. So, along that discussion around certification, I think there's a question around how does this play into type certification of the new eVTOL airframes, and what's your opinion on that? And it's kind of a dual part to the question is, how do you see that also impacting A&P certification for eVTOL airframes? So to do maintenance on them. So
Yeah, good question. So I'm sorry, the first question was how does AAM and new technology play in? What was that again?
Yep, that's right. Yep. How does the how does that, I think, go into the curriculum for aircraft certification, and then of course what you think that looks like? Just kind of what your thought process is, your opinion on that, and how that might affect the industry.
Yeah, the companies that producing AAM, and they're myriad, are facing this challenge, and they're looking for those with the certification skill set, but they're also approaching it differently than legacy aircraft producers. They're helping us rethink some of the things that perhaps needed to be rethought, but there is a process for certifying the new technologies, and the roadmap, frankly, is being built as we speak. It's part 23. We now have vehicles that are very, very close, if not already past that threshold for part 23, and which means total integration into the airspace system. And so they have passed that hurdle and have demonstrated that equivalent level of safety, maybe not in the same way, but they've created some new paradigms when it comes to the new technology, because there are systems and challenges that they present that just haven't been addressed before. And so it's stretching the whole industry, but the FAA is responding. They're responding well. They're already starting to put together, there's already a committee for how do we start to regulate space operations and space transit through the airspace. And we have to do that very differently. So there is going to be a process. What that process looks like, though, we're building it as we go. And as far as the mechanics and the need for maintenance, that's one position that I don't think you're ever going to be able to automate. I think the need is going to continue to grow. It's going to become more diverse, and they're going to
Right.
currently going to have to be exposed to a wider range of technologies.
That's what I was curious about, what your thought process was in terms of, do you see a certification, like a separate certification process on the AAM side that bolts into it, or do you think it's just going to be integrated into it? And
You know,
we do that now.
there are ASTM committees right now that have produced standards for just exactly what you're talking about now. And so it will be, I don't foresee a new certification from the FAA, but I do foresee required bolt-on training because, you know, really at the end of the day, it's an aircraft that flies through the air. And when you know, whether it's going up to space or whether it's got multi-rotors and, you know, whether there's a pilot or a crew on board or not, the system has to be maintained. And there's such a convergence of technologies, right? That convergence that, you know, we're seeing technology, we're seeing the technology vector for AAM start to impact legacy aircraft, and those systems are being retrofitted, and so there's going to be a blending, but I don't see a different certification.
Hey, Kurt, getting back to Randy's question about jamming and spoofing and things like that. Your equipment is not going wrong. You're being attacked by some hostile intent, right? So under those circumstances, how? I mean, spoofing. Your equipment is working fine, right? So would that necessarily? I mean, this depends on your environment, right? So if you're going through what environment where you're like, if someone shoots you down with a missile, that's another thing, right? So yeah, I mean, like we in terms of navigation, at least, I'm really not sure. Like they basically talk about those things at all. I mean, in terms of what
Yeah,
environments.
those are good questions. I mean, so one of the main things that differentiates the military airworthiness certification process from the civil certification process is that you know, military systems have that added layer of having to operate, having to harden their systems to operate in hostile environments, and so they do have to take those things into account. Up to this point, for the most part, we haven't had to consider that in civil aircraft design. Will we in the future? You bet. I mean, that is going to be a huge skill set that we're going to have to borrow from the military side because of the potential for what you're talking about, you know, navigational spoofing. We just haven't operated under that set of assumptions in the civil world in this country and most of the rest of the, you know, the countries that use our standards. But that's changing. That's a good point.
Unfortunately, it may be already clear, guys.
Yeah. Hey, real quick, just from a time check, I got one more question, and then I want to see if there is a question from the crowd here. If anyone's got one, we do have a student question, so I do want to get over to that. Dr. Barnhart, do you mind just elaborating in like 1 minute give us a little bit of background on the designated engineering status for the MSA program that you're pursuing with the FAA? Because I think that might be some good info for the crowd out there. So
Yeah, for sure. So recently, the FAA has created a process by which academic degrees. See, when it comes to certification, academic degree programs, the two have never met. It's just a foreign language to most academic programs, and so since now we're starting to broach this in an academic sense, the FAA has said, okay, we're going to vet programs according to content and see whether or not it can apply as credit towards a designated engineering representative or the DER process. Currently, it's an 8-year process. If you come with an undergraduate degree, they automatically they credit you with 4 years of that 8. But it is different because it requires an engineering degree. So that's one thing that does set it apart. But the master's program, we're pursuing that certification or that accreditation to be able to to have it count for an additional year. So in other words, out of school, you could have 3 years on the job training and then become a DER, which basically, is the FAA relies on DERs to do a lot of their certification work. And as the workforce in the FAA becomes more constrained, they do more and more of that. There's also a DAR. We could go on and on, but there's a designated airworthiness representative, which is similar, but yeah, there's a lot of conversation to be had there, but we're in the process.
Excellent. Excellent. So thank you. Yes.
Yeah. My name is Christopher Matty, current student here at K-State. I'm just wondering how established the program is. It sounds like this is relatively new, but you had something going before that a little. And where are you pulling the faculty and staff for some of these courses? Like, I assume the Lean Six, that's been an established course already for a while. Is a lot of this coming from the main campus? And I don't know, just if you could speak on that.
Yeah. So, like I said earlier, we have some faculty across campus doing some of the support courses in advanced technical communications and research methods. Then current aviation faculty are delivering a portion of the courses. And then I do have adjuncts, part-time faculty, I think is the official K-State term, to help deliver some of the coursework. But say, for instance, project management, Fred and Sue Guzek are going to be helping with project management. In fact, we've got a conversation following this to talk about that and how that works. And so, so people from industry, people from K-State, nobody from Manhattan yet, and then folks from this campus. Currently, that's who we have.
Excellent. There was the
I'm not-
question, a follow-up question is how much of that is adjunct? I think I guess
Currently,
percentage roughly, high level.
percentage of the certification option, I don't know, I would say maybe 15-20%. And
That's
then
not bad, right?
on the leadership policy side, maybe 10.
Did the AI get, like, if I did a thumbs up, did it just give a thumbs up on? It'll do. I didn't know that. Okay. All right. Well, then I learned something new every day. I was like, who hit the button to give a thumbs up? And then anyway, sorry. We have a conversation on this side. Any other questions? All right. Okay. Well, I think any other from online? One more, maybe? Time for one more? All right. Well, I think that just about covers it for this. I appreciate it. Thank you, Dr. Barnhart, for your time. I appreciate that. One more thing that I want to talk about real quick for those out there. We had, as part of our agenda today, we had the Research Connections, which was yesterday. That's a big event that we have in Manhattan. It's an annual event. They hand out awards. They get all the researchers together, and then we get across campus. We get to collaborate and kind of see what's going on across what other departments and what other colleges are doing at K-State. Technology perspective, people kept coming by going and saying, you guys have the coolest booth. So that was pretty cool. So it was a lot of good handshaking. VPR stopped by, Dr. Rosowski stopped by, was able to meet and greet with Dr. Rosowski, Dr. Monalone. So it was a good, we had a bunch of innovation partners were there. So we were able to kind of get a lot of good press out of that. While that was going on, I was also, I was at both areas, but the graduate school held a brainstorming session. I was there as well. And that was a really good session. So we talked about professional, I should say, let me rephrase that. Degrees that were marketable, grad degrees that were emphasized towards working professionals. That was a big part of the discussion. Not just for masters and graduate certificates, like what has normally been the case, but also for PhD programs that also entertain and are accessible towards working professionals. So it was good. It was, I want to say, about 100 people were almost there. I mean, the room was packed. So more to come on that. I'll have more details, but again, we had a good representation there and a lot of good information out of that. It went from how do we improve process to how do we get rid of CollegeNet to so Dr. Barnhart, I know you're appreciating that one. How do we get, because I am in the same boat, how do we get rid of CollegeNet? But I was sitting right next to Michaela, Dr. Lenhart, I believe she just started. She came from Rockhurst, and she's spearheading that effort. So I was able to chat with her a little bit. Claudia was able to chat with Dr. Petrescu a little bit as well, in advance of her coming out later this month, or I should say, November 1st. So she'll be out here, and we'll be able to, I think, I'm looking at Professor Harding here. If I did mention about getting Dr. Petrescu in on the zombie taco truck, because I believe the 1st is the very last day we might have it up and running. So no promises though. Yeah. So that'll be fun. She was excited to hear about that. So that's all I've got from my end. If you're interested in learning more about connecting with any of us about anything related to research or grad programs, of course, I'm available. But also the department heads are available. So Dr. Gaddert on the aviation side, as well as Dr. Barnhart for the MSA program, the aerospace certification, as well as the leadership and policy and aerospace safety option. If you're interested in learning about integrated studies, you have Professor Harding, who's over here, as well as myself on the ISD side. And I think that just about covers it. Just one last public service announcement. The ISD, this open coffee forum, we'll be doing ISD in November, so be on the lookout for that. And that's all I've got. Dr. Barnhart, did I miss anything?
No, I don't think so. Michael provided some comments in the chat, but it basically was what you just said. So I think you got it.
All right, good deal. Well, that's all I have. Is anybody else? Last call for questions, last call for ideas and or comments. All right, good job. Nice work. Thank you, Dr. Barnhart, and we will see you on the other side.